Now the solar wind comes into the Earth's edges through the magnetic field. It comes down to the magnetic field, and some of the particles from the sun are trapped in the magnetic field, and they flow down into the ionosphere. Here, the sun is flaring. It's creating particles that are carried on the solar wind. It reaches Earth and it comes down through our magnetic field to the poles, North and South Pole. That's why there's a northern lights and a southern lights, because it comes in at the poles. And the ionosphere is a section of the Earth's atmosphere from 35 miles to 175 miles above the Earth's surface. So auroras occur along ring-shaped regions around the north and south poles, the geomagnetic poles. These are called auroral ovals or zones, and they spread out when there's more sunspot activity, and they grow and contract, these auroral ovals, hourly and by the minute. Auroras are more frequent and spectacular during solar storms. You can see Alaska here. This is the auroral oval from space. Isn't that fascinating? During solar storms, the solar wind can generate 100,000 megawatts of electricity. It causes interference with power lines, radio, television, satellite communications, and GPS. Canadian nuclear power plants are protected against solar storms, but the US power grid, not so much. And that's because the auroras are less common in the United States. Remember, the greater the solar storm or sun